Hello, welcome to Chapter 1 of Geometry, Homework Questions 105 to 109. Question 105. On graph paper, graph each of the lines below in the same set of axes. What is the relationship between lines A and B? And then what about B and C? So let's go ahead and graph the lines, and then we'll make our determination. So line A, I'm going to go ahead and graph in blue with a y-intercept at 0,4 and a slope of 1/3. Just to make sure, since I don't have a straight edge on here to do this, I'm going to plot a bunch of points so I can get the most accurate line possible. So we're going to call this will be y equals 1/3 x plus 4. The next line I'll do in red. And we have, let's see, negative 3x plus 4. So same y-intercept, but a different slope. So down 3 and to the right 1. Once again, get quite a few points on here, and then I can also go up 3 and to the left 1. That still gives you a negative slope. Alright, and this equation is y equals negative 3x plus 4. Anytime you're graphing multiple lines on a coordinate plane, make sure you label your lines. And then on C, we'll go ahead and graph that one in black. And that is negative 3x minus 2. So same slope as the one before, but different y-intercept. So here's the y-intercept, and then we're going to go down 3 over to the right 1. We can also go up 3 and to the left 1. So still that same slope. And you can see that the red and the black line appear to be parallel. And if you look at their equations, you'll notice that they are because they have the same slope. So now let's go through and make sure we answer the question, what is the relationship between A and B? So the relationship between A and B is, you'll notice that they have opposite reciprocal slopes. So therefore the blue and the red line here would make a right angle. And we know that because their slopes are opposite reciprocal. So A and B are perpendicular. And then it wants to know about B and C. So let's take a look at B and C. B is red and C is black. And we just talked about those a little bit ago, that they are parallel because their slopes are the same. And we have now answered all the questions. Question 106. The length of a side of a square is 5x plus 2. If the perimeter is 48 units, complete the following. So if we know this is a square, then 5x plus 2 is the length for all four sides. Write an equation to represent this information. So because it does give us the perimeter, a couple different ways we could write the equation. I'm going to go ahead and do 4 times 5x plus 2 is equal to 48, and that's because instead of taking 5x plus 2 4 times, I'm just going to use kind of the shortcut with multiplication. But either way is fine. Part B, it wants us to go ahead and solve. So I'm going to take this equation and actually, instead of distribute, you could distribute. I'm going to divide by 4 first. That'll give me 5x plus 2 is equal to 12. Subtract the 2. Divide by 5, and we get x is equal to 2. And then on part C, it says, what is the area of the square? So now we know what x is. Then 5 times 2 plus 2 will give us the side length of 12. So now we know that each side length has a unit of 12 units. And so therefore the area is length times width. So 12 times 12, or 12 squared, which means we have an area of 144 square units, or units squared. Question 107. What is the probability of drawing each of the following cards from a standard playing deck? See the entry playing cards in the glossary to learn what playing cards are included in the deck. We got the probability of pulling out a jack. There's 52 cards in a standard deck, 4 different suits from ace, king, queen, jack down to 10 all the way to 2. And so there are 4 jacks in the deck. So the probability of pulling a jack is 4 out of 52, which could then be reduced to 1 out of 13. The spade, as I said, there's 4 suits, so that means there's a total of 13 spades in a deck. So 13 out of 52 would reduce to 1/4. The probability for pulling out a jack of spades. Now, there's only 1 jack of spades in every single deck, so on this one, that's a probability of pulling 1 out of a possibility of 52 cards. And then the probability of not pulling a spade, so that's hearts, diamonds, and clubs, that would give you 39, because there'd only be 13 that are not, or 13 that are spade, so 39 that are not spade out of 52, which reduces to 3/4. Question 108, examine the figure graphed on the axes at the right. You can also use Desmos as well. What happens when you rotate this figure about the origin 90 degrees, 45 degrees, and then 180 degrees? So you can use Desmos. You can also use your tracing paper to help you out with these as well. But if you rotate the figure about the origin, so it has to be right here, 45 degrees, 90 degrees, and 180, just to kind of show you, this would be like your 45, your 90, and then your 180. What you'll notice is that each one of these rotations happens on a point, and so what's left is the original figure. It looks exactly the same as the original. B, what other angle could the figure above be rotated so that the shape does not appear to change? And it can be, in terms of if you're looking right here, every 45 degrees, it hits that kind of outside point there. So any multiple of 45 degrees would work where the figure would not change. And then part C, what shape will stay the same no matter how many degrees it is rotated? So this doesn't have anything to do with the figure at the right. It's just asking the question, what shape, or is there a shape that will stay the same no matter how many degrees it is rotated? And there is a shape, and it's called a circle. And that one doesn't matter because it'll always appear as the original. Question 109, copy the diagrams below on graph paper, then find each result when each indicated transformation is performed. So looking at reflections and rotations on this one, it wants you to reflect the figure A, figure A across line L. So since we're reflecting, it has to be the same distance away. So I'm just going to take each of these points on the figure, wherever there's kind of a change in direction there, and I'm going to I'm going to reflect each of those. So that's 1 unit away. The next one is 5 units away. So same thing here. You have another point there. I'm just counting. So this point is 1, 2, 3, 4 away. So I'm going to go 4 on the other side. And then I can just connect the points. Be careful when you connect them because they have to form the figure from above. And there you go. So that would be I'll just call it A prime in terms of its figure. On B, rotate B 90 degrees counterclockwise about point P. So this would be a good opportunity to probably use your tracing paper unless you can visualize it. Obviously I can't use the tracing paper here, a little bit hard to do, but I'm going to go ahead and rotate it. Remember, it is counterclockwise, so this is the direction. You're going this way, and we'll see what we get. And so there would be your 90-degree rotation counterclockwise. On part C, rotate C 180 degrees about point Q. So we're going 180 degrees rotating around the point Q. It doesn't give a direction. One of the things that we learned with the 180 degrees, it doesn't matter which direction you go, it's the same location. And there is figure C. On D, reflect D across line M. And so you can count directly across on each of these points. So you can say this is one diagonal of a square. And so then you'd go one diagonal of the square here, and there would be a point here. Another way that students have done it is they'll count down to the line. So 1, 2, 3, 4. And then you can go 1, 2, 3, 4. And then that point will reflect over there. So as I said, there's a couple different ways that you could look at that. You could just count straight across, or go down and then left or right as well. And there represents the new figure D.